Hey guys, just wanted to do a little video here on the rain caps from the layout test. So there was two questions. There's one asking for a chord length for a rain cap with a 10-inch diameter, which would look like this. So 10-inch diameter, and it had a 30-degree rise to it. So the first thing we're going to be doing for a question like this, before I go on to that, the other question was asking for an arc length for a rain cap with a 20-inch base. So we're going to do the 10-inch one first, because we can actually use a lot of the numbers from the 10-inch one to figure out the 20-inch one. So first thing we're going to do is we need to find the slant height on this cone, right? So this rain cap. So to find this hypotenuse, I'm gonna find out what the rise is here. So they're from here to here. So I can use basic trigonometry. So if I cut this whole cap in half, this ends up being 5 inches here, a 30-degree angle. So I have an angle, I have adjacent, and I'm looking for opposite. So that's a tan function. So on my calculator, if I go tan 30 times 5, it gives me 2.887. Obviously it's more than that. I'm just going to round this off for ease. So again, I can use trigonometry to find out this side here, but I'm just going to use Pythagoras Theorem. So I'm just going to go a squared plus b squared equals c squared. So I'm not even going to do anything with that number. I'm just going to square it. And then plus 5 squared equals, and then square root that. And I end up with 5.774 for my slant height, or hypotenuse on that. So that's going to end up being the radius of the circle that I need to that's not a very good circle. Oh dang, what the hell am I on something? Okay, anyway. That's going to be the radius of the circle I need to make that rain cap. So 5.774 radius. But I need to have a chord length. So there's going to be a little piece of pie that gets cut out of that circle, so it'll form the rain cap. And I'm looking for the chord length here. So the first thing I need to find is this angle here. So that's going to be from that radial line worksheet. So the formula for that is, so that's the stretch out angle. So that's going to be 180 times diameter divided by slant height. So 180, we have a 10-inch diameter, divided by our slant height of, or radius, which is 5.774. So on the calculator, 180 times 10 equals, divided by 5.774 equals, so all the way around, that's 312 degrees. Now I don't really care about that. What I'm looking for is the degrees in here. So 360 divided by 360 minus 312 is going to be 48 degrees. So we have 48 in there. But to find this chord length, I need two right triangles. So I have to draw a line in there. So I have a right triangle. So all I really care about is 24 degrees in this one. So if I take that triangle out, I have 24 degrees for right here. I don't have the baseline here. I do have the hypotenuse, because that radius, no matter where I put it on the circle, is going to be 5.774. So my hypotenuse here is 5.774. So now I have hypotenuse, and I'm looking for opposite. So that's a sine function. So now if we go with sine 24 times 5.774. That gives me 2.348, so that's going to be the opposite. But that's only giving me half of that length of the chord. So if I take that 2.348 and times that by 2, it gives me 4.6969947, etc. I'm just going to turn it into a fraction though, because all of the answers are in fractions. So it's going to be 4 minus 4 off of here times 16 gives me 4 and 11/16, which is the right answer. Hopefully that made sense. Now for the second question, where it was looking for an arc length for a ring cap with a 20-inch diameter, if that was 20-inch. All the other information's the same. It's a 30-inch angle or a 30-degree angle, etc. So all I need to do is double that radius there, and then I'll have all my information for a 20-inch one. So if I take that 5.774 times 2, that gives me a radius now of 11.548. And to find an arc length here, it's just a little piece of a pi. So if you remember, the formula for that is radius times 2 times pi times angle over 360. So my radius is 11.548 times 2 times pi, and my angle is 48, right? We're not using the half of the angle this time, we're using the whole one. So 48 divided by 360. So I always do this part first. So that 48 divided by 360 ends up being 0.1333 continuing. So now I can just figure this out. I already have the 11.548 on my calculator. So times 2 times pi times 0.1333, etc. And that gives me 9.674, etc. So again, turning that to a fraction, that gives me 9. So minus 9 equals, and then times 16, 11/16. Yeah, so because I rounded things off a little bit on here, I ended up with a number that's a little bit smaller. So if you keep using, like, you should be using the full numbers instead of rounding off, because the actual answer here is 9 3/4. So I ended up losing a 16th there. But anyway, you get the gist of it. This is the right formula to be using. This number here would have been slightly larger because if I continued with all the decimals. But I don't think there was an answer on the answer sheet that was 9 11/16. So you could have probably figured out that you'd just round it up to the 9 3/4. So anyway, hopefully that helps explain how to find the answers on those. But yeah, if you have any questions, just give me a call or text, and I'll be happy to help.